Good morning, good afternoon, good evening, whenever it is that you have a chance to watch this video. Hopefully yesterday you were able to go over your proportional and non-proportional lesson. If not, please go back and do that and then come back to watch our video today. Proportional or non-proportional relationships. If they are proportional, they have a constant ratio or unit rate. So what are ratios? Give me an answer. Try to think about it. They are fractions. Yes, ratios are fractions. And then now let's talk about a unit rate. What is a unit rate? A unit rate is a fraction that has a denominator of 1. So for example, 12 to 1 is a unit rate. So let's go over some of those examples that you guys, the got it problems that you were supposed to do yesterday. So for the first problem, problem A stated, at Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at the school proportional to the number of teachers? And then we needed to explain. So it says there's 48 students to 2 teachers. We need to see if we can make this a unit rate. So you start with your fraction, 48 over 2, because it's students to teachers, and then we reduce by 2, because you're just reducing it a fraction just like you would do for the ratio. So 48 divided by 2 is, yes, 24, and then 2 divided by 2 is 1. So because we have 1 in the denominator, it is a unit rate. So yes, they are proportional, because the ratio creates a unit rate. Let's go, and hopefully you have your paper with you and your book on page 35 to the Got It B. So this question says, at the beginning of the year, Isabel had $120 in the bank. Each week she deposits another $20. Is her account balance proportional to the number of weeks of deposits? Use the table below and explain our reasoning. So first of all, you want to look for the keywords in that story. Okay, in the story it says she already had $120 in the bank. And this is when we, if you remember back before we had our long break, that we make an equation. If she started with $120, you put $120 first, because that's what she starts with. But then she's adding $20 a week. So that would be plus $20, and our per week is X. So if our equation is $120 plus $20 per week, to figure out the chart, our time is the week. So in 1 week, so we would take 120 plus 20 times 1. So that's just 120 times plus 20, which is 140. That's week 1. Week 2, we start with 120 plus $20 times 2. So that's 120 plus 40. So 120 plus 40 is, yep, 160. Week 3, we have 120 plus 20 times 3. So that's 120 plus 60. So 120 plus 60 is, yep, 180. So then we're asking ourselves, is this proportional? The answer is no, it's not proportional. And we know it's not proportional because we can come down here and we can look at our equation. If you remember before, I said if you ever start with something and add to it, it can never be proportional. So then if I look up here at my proportions, I'm going to take y over x. So 140 divided by 1 is 140. 160 divided by 2 is 80. So do those fractions equal each other? No. 140 does not equal 80. So therefore, because in looking at this equation, we know that it's not proportional. Those were your 2 got it problems yesterday. So let's move on to the guided practice. You had an option to either do the guided practice with the quick check, which is online, or you could have done the actual 3 problems. So I'm going to go over today the 3 problems. Make sure you're on page 36 in your book while I go over this, please. And hopefully we can get it all in here and so you guys can see it. So number 1 in the guided practice states the Vista Marina rents boats for $25 per hour. In addition to the rental fee, there's a $12 charge for fuel. Use the table to determine if the number of hours you rent the boat is proportional to the total cost. Again, look at our keywords, okay? It said that it's $25 per hour, okay? So we've got Y equals $25 and my X equals the number of hours. So $25 per hour, but then it also says in addition, so we're gonna add $12 charge. If you think about what I just said in the last problem, just by looking at the equation, we should be able to know, hey, this is not proportional because we have an addition sign, but let's fill out our charges to make sure. So if it's 1 hour, so I take 25 times 1 plus 12 gives me $37. 2 hours, you fill it in. 25 times 2 plus 12. So 25 times 2 is 50. 50 plus 12 is 62. And then 3 hours, you do the same thing. 25 times 3 plus 12. 25 times 3 is 75. And 75 plus 12 is 87. So the answer to this is no, not proportional. Okay? Again, we could have found that just by, if you start by making an equation, sometimes you don't even have to fill out the chart because it'll make it easier. We can say, okay, no, I've got an addition, but you have to carefully read the story problems to know that. Number 2, it says which situation represents a proportional relationship between the hours worked and the amount earned for Matt and Jane. So what we do is you just take the hours worked and the money earned. So this is Matt's chart, and down here we have Jane's chart. So if I take 12 divided by 1, I get 12. If I take, so that was 12 divided by 1. This is 20 divided by 2 equals 10. 31 divided by 3 equals 10.3. And you're going to want to make things faster. Just use your calculator. That's why I said in the assignments, use your calculator. But as we can see, 12, 10, and 10.3 don't equal each other. So again, this, I can say that Matt is not proportional. But let's check on Jane. 12 divided by 1 is, 12. 24 divided by 2 is 12. And then 36 divided by 3 is 12. So all of these, 12, 12, and 12 match up. So the person who has the proportional relationship is Jane. But you needed to make sure you've checked both, using both charts and finding it out. We were just doing easy division, and to make it quicker, you can always, again, use your calculator. So those were the 2 problems in the guided practice that I want to go over. The next thing I want to go over, make sure everybody, you guys are right now on page 37. Okay, get to page 37 and we're going to work on some of the independent practice problems. We will start with number 1, and there's just a few that I'm going to do today, and I might skip a few here and there. So reading through the problem, it says an adult elephant drinks about 225 liters of water each day. There's our clue word, each. Is the number of days the water supply lasts proportional to the number of liters of water the elephant drinks? So, in the chart, they've already given us the number of days. We need to figure out how much water that is. So as we fill that in, it says 25 liters each day. So I'm going to make my equation. Y equals 225 liters each day, so that's times my x. X equals number of days. Am I adding anything or subtracting anything to this equation? Okay, the answer is no. So I'm definitely doing multiplication or division only. So I can tell you right now, without even filling out the chart, that it is going to be proportional. So let's just figure out. 1 times 225 is 225. 225 times 2 is 450. 225 times 3 is 675. And 225 times 4 is 900. If I go through and make a proportion, I can say time of days to water, it's 1 to 225. Okay, if I reduce that fraction. If I reduce this fraction, make it a fraction divided by 2, each one, it becomes 1 over 225. If I do that to the next 2, it's the same thing. You get the same answer. Moving on to number 2. An elevator ascends or goes up. Remember that word. You need to remember those words for the integers. Ascends means going up. Descends means to decrease, which would be a negative. But it ascends or goes up at a rate of 750 feet per minute. Okay, so I'm going to start with my equation. 750 feet per minute. Per means like it's dividing, so it's timesing it by the minute. So x equals my minute. Is the height to which the elevator ascends proportional to the number of minutes it takes to get there? If I just look at this, it's a multiplication problem. It is going to be proportional because I'm not adding anything and I'm not subtracting anything. So 750 times 1, because it's 1 minute, would be 750. 750 times 2 is 1,500. 750 times 3 is 2,250. 750 times 4 is 3,000. So as you can see, we're filling up these charts and showing, make an equation, work the equation, fill it into the chart. You would do the same thing with number 3. But let's move on to the extra practice. So turn in your books to page 39. So I want to go over another example, and we'll be looking at number 11. Again, notice I already said put an equation here. Fill out an equation before we fill in the chart. So it says to convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the Celsius temperature by 9.5. So it says to multiply. So 9/5 times the Celsius. So I'm going to say x equals Celsius degrees. And then it says, and then add. So then add 32 degrees. Is the temperature in degrees Celsius proportional to its equivalent temperature in degrees Fahrenheit? I can answer that right now before filling out the chart. I am adding something in my equation. So y equals the 9/5 times Celsius plus 32. If I'm adding something, it's not going to be proportional, but we still need to fill in the chart. So you take 9/5 times 0, because that's our first degree Celsius, which is 0. So 0 plus 32 is 32. Then I do the 9/5 times 10, which would be 90/5 plus 32, which comes out to be 50. Then 9/5 I'll show you this one, times 20 over 1 plus 32. Okay, I'm going to cross multiply. The 5 becomes a 1, the 20 becomes a 4. 9 times 4 is 36, and then 36 plus 32 is what? Yeah, 68. Okay, and you do the same for the last one, which your answer would be 86. So again, filling out the equation helps first, then you must still fill out the chart. I'm going to help you out for tomorrow. Tomorrow you're going to do an IXL, your choice. You can do IXL or you can do the book pages. But what it's going to look like on the IXL is you're going to do K7, and you're going to work for 15 to 20 minutes. And you're going to compare the two charts. They're going to ask you which one is a proportional relationship. And so you have to look at two charts, and they'll have a check mark on the bottom. I'm sorry that you can't see the bottom of this page real quick. Let me try to move it so you can see it. This is just an example I pulled up yesterday to see whether or not they are proportional or not. So you have your X and you have your Y, and you'll give you two different examples. Always, to find if it's proportional, always do Y divided by X. So here we have Y, which is 2. So you're always setting up your table. X is first, Y is second, always alphabetical order, especially your X-axis and your Y-axis. So if you're looking at it like this, you have your graph, you have your X-axis and your Y-axis. It's rise over run. So if it's always rise over run, it's Y over X, because this is my rise, this is my run. So I take Y, which is 2, divided by 5, which is 2/5. Then I take 4 divided by 10, which if I reduce it by 2, I get 2/5. 6 over 15, I reduce by 3, and I get, again, 2/5. So if they all equal 2/5, this one must be proportional. Let's check the second chart, the second table. Y over X. So it's 3 over 1, which actually reduces to 3. 6 over 2 reduces to 3. 9 over 3 reduces to 3. They all equal 3. So that one is also proportional. So you don't have to just choose one, you can choose both. So in IXL tomorrow, I would click both boxes. I hope you guys have learned something through our lesson today, and you practice real hard tomorrow. Make sure you take a screenshot of your time and your score and submit it to the Canvas assignment that I created today. Stay safe and have a good day, and I'll see you again.